into the vertical blank.
Hi, this is 8-Bit Rocket Jeff Fulton from the Into the Vertical Blank podcast and YouTube channel. Today we are going to continue our series on STOS basic tutorials. This one, number 3, will start by looking at the stoscoders.com Visual Studio plugin. We'll discuss integrating it into Atari and STOS, and we'll create a simple sprite to use in a Hello World example of the MissingLlnk STOS extension for horizontally pre-rolled sprites. Neil Holliday's stoscoders.com site and link are on the screen now. I suggest you go to his tutorial linked in the show notes. It will give you all the basics for setting up and using the VSCODE plugin. Also, there is a full text and graphic tutorial companion for this tutorial linked in the show notes. It will give you more background and also links to tutorial number 1 and tutorial number 2. Number 1 is on setting up Atari and the entire environment, and also will give you a download of everything you need. But in this video, we're going to bypass the stoscoders.com tutorial, and we're going to start our own STOS project in VS Code right now. So let's go there. So go ahead and start up VS Code. Make sure you follow the stoscoders.com tutorial to install the latest STOS plugin for this editor. I have both the Atari Dev Studio, which is used for 2600 and 7800 development, installed, as well as the STOS plugin. Best thing about the STOS plugin is that it eliminates the need for line numbers. The first thing we're going to do is create a new STOS project in VS Code. What we need to do before that is to copy the full path of our toots folder on the GemDOS hard drive that we're using with Atari. Let's find mine now. Okay, in Explorer you can see the toots folder that is inside my STOS development GemDOS hard drive. In Windows, I can right-click on the toots folder and save the name as text. Then I can paste it directly into the project setup in VS Code. Back in VS Code, use Ctrl-Shift-P. This will bring up the command palette. Next, type in STOS new and enter. Paste in the location of the toots folder in the GemDOS hard drive and hit enter. If you want to use a similar setup to mine, check out tutorial number 1. Next, give the project a name. Use lowercase mlink for MissingLlnk and hit enter. Next, it will ask if the name of the build file will be stosbuild.asc. For this project, the answer is yes, so hit enter. Now it will open the editor into the mlink folder. We will build the .stos file into a .asc file with Ctrl-Shift-B. The .asc file will be located in the STOS folder. Since we created a .stos file with only rem statements in it, it won't show anything on the screen, but it's a viable .asc file that we can load into STOS and run. Let's demo that now. Ctrl-Shift-B. The terminal window will give you the status of the build. The build.asc file will be placed in the .stos folder. This ASCII file can be imported directly into STOS. We also need to place any assets like images, sounds, or memory banks that we need to use for our programs in this STOS folder. In our mlink folder, you will notice that every time we build, we're giving it the name build.asc. As we progress through the tutorials, we'll rename our final files to things like toots.301.asc, etc. This will give us an archive of our code and our ASCII files. We'll also have .bas and .tos file versions after we compile. Remember, if you want to learn more about the secrets of the VS Code plugin, such as replacing gotos with labels, check out stoscoders.com. Next, we're moving straight to STOS inside Atari. To open up a .asc file in STOS, we use the fload star.asc command. My folder will most likely be different than yours. Find the mlink folder in the GemDOS hard drive attached to Atari. Find and choose build.asc and hit enter to open it. The file will be imported line by line into the editor, overwriting and inserting the contents into the code memory. This file should look just like the VS Code project build.asc because it's the exact same file. Again, it's just filled with rem statements, so when we run it, it will not execute any commands. This is our basic pipeline for getting files from VS Code into Atari and into STOS. Now that we have these basics down, it's time to move to the STOS sprite editor and create a small bank of STOS sprites for using in our further examples. It's time to load in the sprite.acb accessory file. In the file dialog, we need to hit previous a few times to find the ACB folder. Change the file spec to star.acb. We want the sprite.acb file. The sprite2.acb file is for medium resolution sprites. Find sprite.acb and hit enter. Type run. You will see the powerful original STOS sprite editor on the screen. First thing we will do is import the Degas tilesheet I created from Ari Fleischmann's SpriteLib. We'll click on the import icon. Then we'll highlight the palette icon to ensure the palette of the sprite designer changes to the palette of the loaded in file. We click on Degas and it will bring up a file selector box. The provided asset subfolder of toots contains sprites.py1. Select this file, hit enter, and it will load. This will give us 2 frames of a pulsating eye in the top left corner. We need to use the mouse to draw a box around the image. This will put it right into the sprite editor. Note, use Alt-M in Atari to keep the mouse constrained inside the Atari window. And click Alt-M again to take you out of this. Draw a red box around the image to select Sprite 1. There's the sprite. There seems to be a green accent at the top that's missing in both Degas and in our sprite. I'll add it now to make it more symmetrical. You want to grab the entire image. Don't worry about it not being the exact size around the bounds of the image. We can get rid of any extra space in the next section. Let's use a built-in function to orient the sprite to the top left corner. Click on the XY ruler. Next, click on this icon, which means to push the sprite to the top left corner. It's pretty cool. Next, we want to add the new image we created as a sprite to the library in position 1. We click on the M-like icon to access the library commands. The center icon with the question mark on it will stamp our current sprite into position 1 in the library. Notice it scrolled the library to position 2 to get ready for the next sprite. To add sprite frame 2, we're going to repeat these same steps. First, back to the Start menu. Now, image grab from the file. Use the Degas file type. Again, make sure the palette is selected. Find and choose sprite1.py1, the non-compressed Degas file. Next, we grab the second sprite by highlighting it with the red box using the mouse. Click to select. It will show up back in the sprite designer. Click this tools icon. As with the first frame, I want to add the gray accent at the top of the sprite. This is just because of me. This is not 100% necessary. The STOS sprite editing tools are rudimentary, but they're very good for the job. Now it's time to use the measure tool and the right-hand corner relocate tool and position to 0, 0. Next, we'll make sure the width of the sprite is no bigger than 16, which is the shortest we can use in STOS. We will also make sure the height is as short as possible. This does not need to be 16, it can be shorter. I think 8 is the minimum, but it could even be smaller. To do this, we click the measure tool again. In the upper right-hand corner of the sprite designer, we can change the height and width with the measure lines. It looks like 16 by 11 is a good set of dimensions for this second frame. Watch out, the tools are a little touchy with the emulated ST mouse, but it still works well. We need the width at 16, but keeping the height as small as possible will save memory as we create our pre-rolled versions of this sprite. We need to go back to the main menu and then to the sprite insert commands and drop this new image into position number 2. Now we are ready to insert frame 2. As I recall, I didn't resize the dimensions of frame 1. So we're going to need to re-grab it from the sprite list into the edit window, change the dimensions, and then replace it back into position 1. Using the bottom of the 3 sprite manipulation icons, we can pull the sprite out of the library into the edit window. I wish these were more intuitive looking, at least for my sake. So now frame 1 is in our edit area. We can go back to the measure screen. Let's repeat what we did for frame 2. This time it will be 16 by 10, not 16 by 11. Click back to the main menu. Click on the Sprite Library Manipulation Tools. Make sure you scroll to the left of the library to highlight frame 1 and click the middle icon of the sprite manipulation icons to replace it in the library with the one we just edited. Yay, we have 2 frames. Now it's time to save the sprite bank. Go to the main menu, click on the disk drive icon. I always use the arrow to the disk with the question mark icon, which is save as, so I never accidentally overwrite one of my files. In the current toots asset folder, there may already be a sprites1.mbk, especially if you downloaded the tutorial files and are using that folder as your working folder. It's okay to overwrite the provided file with the new one. If it's already there, it will ask you if it's okay to overwrite. It is. Now exit STOS Sprite Editor and we'll use the MissingLlnk make utility to create our pre-rolled bobs from these STOS sprites. Next, we are going to create the most simple MissingLlnk BOB Sprites that we can. We need to find the extension folder on our GemDOS hard drive and look for the MissingLlnk folder. Once there, we need to find the tools folder and load the make utility. With this, we can create our own simple 16-position horizontally pre-shifted sprites. After we type run, the utility will load and start to create our bobs. We first need to find and load the sprites.mbk file we created with the STOS utility. We stored those in the toots assets folder as sprites1.mbk. This will load and then we'll create our bobs from it. By going to the make menu and clicking on bobs. If we click in the text images button, it will show us that it is defaulted to 16 images for each sprite. This can be 16, 8, 4, 2, or 1 sprites. Go back and click the make bob data and watch it do its magic. This made 16 24 width bob sprites for each of our STOS sprites. Now quit from this. Save the bobs as bobs1.mbk to the assets folder. You can write over the previous bobs1.mbk if you're using the downloaded files and one already exists. Now the bobs are saved, we can quit the utility. We're now going to go back to our code. If you want to, you can copy bobs1.mbk from the assets folder to the toots MissingLlnk STOS folder. This file will already be there if you're using the downloaded code files. After you do this, go back to VSCODE. I've placed some of my other rendering test code into the toots rendering folder. We're going to load one of those in this step. Go to the file menu and then open, and then find the toots rendering main.stos file. It won't be shown on the screen because I didn't capture this. We're going to copy this code to the toots MissingLlnk main.stos that you will likely already have open from the first step. Now let's go through what we're going to do with this code. Much of this is similar to the Obliterator tutorials, so I'll focus on the new MissingLlnk functions. pbob represents the bob in the bobs.mbk file that we're going to use. Unlike STOS sprites that start at 1, bobs start at 0. That's referred to as 0 relative, and a regular STOS sprite bank is 1 relative. We will use a regular STOS bank in a later tutorial for comparison to this rendering, so this is something good to know. So we set pbob to be the first bob we output, or 0. px is set to 0, which will be the x position of the bob, and py is set to 0, which will be the y position of the bob. Next, we load bob1.mbk into bank 5. The next bit of code is some magic I found on stoscoders.com. It allows you to easily set the palette for the system to the palette from a bank, and we want bank 5 where we loaded our bobs into. Next, we start our repeat loop. First, we use the MissingLlnk wipe command to clear the logical screen. Wipe is a fast replacement for the regular STOS CLS command. Then we draw the bob to the screen with our bob logic start 5, pbob, px, py, and 0. The 0 is unused as far as I can tell at the moment. Logic is the screen. We want to start at the first bob in bank 5 using the memory pointer, and then we have the number of bobs to offset, which is 0. So the bob we will show is the first one. Then the upper left-hand corner coordinates are set with px and py. Next, we do a screen swap and wait for the vertical blank. This will repeat 50 times a second. Then, we're going to do a Shift, Control, or Command B to build this into build.asc in the STOS folder. Now that it's compiled, let's go back to Atari. To keep the mouse contained in Atari, press Alt-M. I made a couple mistakes, so I cut them out. You can see them at the top of the screen, but just type in fload star.asc to bring up the ASC dialog box. Find and select the build.asc to load. If all of the code is correct and Bob's wanted MBK is in the same folder, it should run. There is a Bob in the top left of the ST Atari screen. No magic is involved, but also we're not using any of the STOS commands for sprites or graphics. It's showing Sprite 0 in the Bob bank. Let's summarize what we've accomplished so far in this tutorial. We created a pipeline using VSCODE, the VSCODE STOS plugin from stoscoders.com by Nia Holiday, and Atari for modern STOS development. We showed a method of creating STOS sprites from a Degas file using the sprite editor. We showed a couple tricks on how to edit and position sprites in the editor. We then created a set of Bob sprites from the two STOS sprites using the MissingLlnk utilities. Then we wrote some simple code in VS Code that we transpiled into an ASC file that could be opened and run in STOS. We have a few things left to do. First, we're going to save the build.asc file as toot301.bas. Next, we're going to use the compiler to compile a gem or TOS runnable version of this .bas file. The compiler is a .acb file that we can load in and run from STOS. If you're using the downloaded files, you already have the compiler ready to use. Type new. Use fload and load the compiler.acb from the accessories acb folder. Find it in the acb folder, load it, run it. There it is. Once the compiler is up, we want to set a few basic options and then we'll compile. It's very simple. First, we want our source to be from disk. We want our destination to be from disk, and we want it to run on gem, not in STOS basic. Click compile and choose the source file. It will be in the toots MissingLlnk STOS folder, toot301.bas. Next, choose the object file. It will be in the toots MissingLlnk STOS folder, and it will be toot301.tos. Now compile it. Done. Now we're going to quit and go to gem and test run the compiled version. In both Steam and Atari, it's F12 to reset the machine. Once it's restarted, you can find the compiled file in the toots MissingLlnk STOS folder. Your folders might vary. Once we find toot301.tos, we can double click on it and run it. There it is. That's it. It doesn't do much yet, but in the next tutorials, we'll be adding a lot more functionality to our code. We will animate this, then move it across the screen and add a frame rate counter. In later tutorials, we'll test out other ways to optimize rendering and test other rendering to see if this is faster or slower. If you go to the full text tutorial link, there will be a lot more explanations than have been in this video. I also explain more about saving off your build.asc as a toots301.asc file. Until next time, into the vertical blank.
Into the vertical blank, generation Atari. Into the vertical blank, generation
to the vertical plane.
An 8-Bit Rocket Studios production.